the function fx is given by fx equals x plus 1 divided by x minus 1. Show that f of fx equals x and write down f inverse of x. So what I can do for the first one is, for part A, so we have to prove that f of fx, so a function of a function, that's function of fx, so I can write it as, instead of the x, I'd have to replace it with the function of x, that is x plus 1 out of x minus 1. So I'm going to write x plus 1 out of x minus 1 and then plus 1, because I'm writing this whole thing instead of the x, and then divided by x plus 1 divided by x minus 1 plus 1, minus 1, and that equals that would equal x plus 1 minus plus x minus 1 divided by x minus 1, and this is divided by x plus 1 minus x plus 1, and that's divided by x minus 1. So that would equal, see, the minus and minus go, and here the x and x go, so we are left with 2x out of x minus 1 multiplied by x minus 1 out of 2. So we get that's equal to, the 2 and 2 go away, and that's equal to x. So therefore we have proved that f of fx, a function of x, equals x. And then for the next part, f inverse of x, what that is going to be is, say, if we assume, so we have to we know the answer, I think, but we still have to show the working. If I still have to show the working, so I would do f inverse of x equals y, then I can write fy equals x, and fy equals y plus 1 divided by y minus 1, that is equal to x. So we have to make y the subject of the formula, so we need to make y the subject of the formula. So I'm going to write y plus 1 equals xy minus x. So y minus xy equals minus 1 minus x. Or I can bring the left hand side and say x plus 1 equals xy minus y, and that equals y times x minus 1. So therefore what I get is y equals x plus 1 out of x minus 1, and you see that is equal to fx. So we can say that f inverse of y is the same as fx. So we can say and that equals fx. So without doing this, we could also have said that because a function is self-inverse, so f inverse of x in this case equals fx.